Hi, welcome to my channel. In this video, we want to solve the following problem. Let triangle ABC be inscribed in a circle with center O, with AC equals AB. Let AD be a diameter that intersects BC at E. Connect C to D. Next, from B, draw a line meeting AD at P such that BP is parallel to CD and EP equals 2OP. Given that BC equals 8 units, the goal is to find BP. And now for the solution. First, connect O to C and connect O to B. Since OB and OC are the radii of the circle, we have OB equals OC. Next, consider triangles AOC and AOB. Let us show that these triangles are congruent. Since CA equals BA, AO is common to both triangles, and OC equals OB, the two triangles are congruent by SSS. Since angles CAO and BAO are corresponding angles in congruent triangles, we have angle CAO equals angle BAO. Next, consider triangle ABC and the diameter AD. Since angle CAE equals angle BAE, AE is the angle bisector. Recall that in an isosceles triangle, the bisector of the vertex angle is the perpendicular bisector of the base. Therefore, AE is the perpendicular bisector of BC. Hence, CE equals BE, and angles BEA and CED are both right angles. Following this, consider triangles BEP and CED. Let us show that these triangles are congruent. Since BP is parallel to CD, angles EPB and EDC are alternate interior angles. Since alternate interior angles are equal, we have angle EPB equals angle EDC. In addition, angle BEP equals angle CED equals 90 degrees, and BE equals CE. Therefore, the two triangles are congruent by AAS. Since EP and ED are corresponding sides in congruent triangles, we have EP equals ED. Let us denote the length of the two line segments as X. Next, consider the lines AD and BC and the circle. Since EP equals 2OP, we get S equals 2OP, and so OP equals X over 2 units. If we let the radius be R, then we have R equals OD equals OP plus PE plus ED, which equals X over 2 plus X, or 5X over 2. Thus, diameter AD equals 5X units. So the length of AE equals 5X minus X, or 4X units. Since BC equals 8 units, the lengths of CE and BE equal 8 over 2, or 4 units. Following this, let us apply the intersecting chords theorem. Given a circle with two intersecting chords, the theorem tells us that A times B equals C times D. By the intersecting chords theorem, we get AE times ED equals CE times EB. Substituting gives us 4x times x equals 4 times 4, or 4x squared equals 16. Therefore, we have x squared equals 4. Finally, consider right triangle BEP. By Pythagoras theorem, we have BP squared equals x squared plus 4 squared, which equals 4 plus 16, or 20. Taking the positive root, we have BP equals 2 square root 5 units, which is the solution to our problem. As an exercise, try to solve this problem and see if you can get the correct answer. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching, and see you all next time.